Hello, everyone. Zero product law. So I will not really refer to it as zero product law. We will say find the zeros, find the roots, find the x-intercepts. That's what we will say. It's when we have an equation instead of an expression. We've been dealing with expressions for the first 5 lessons. Now we put an equal sign in. So this first exercise, it is already factored for you. It's not going to be factored for you. So once you get to these factored forms, x plus 7, x minus 3, the zero product law, or finding the zeros, finding the solutions, finding the x-intercepts, what we do is we take both binomials and set them equal to 0. So we have x equals negative 7, x equals 3. And that's it. So solving, and that's what they could say. They could say solve, find the roots. Letter B, 2x minus 5 equals 0, x minus 4 equals 0, 2x equals 5, x equals 5 halves, and we have x equals 4. So those are your 2 solutions. Now, if you factored out a constant, so this 4 right here, to get rid of it, we're going to divide both sides by 4, hypothetically. You do not have to show me this every time. So if I divide both sides by 4, it's gone, and it is still the 2 binomials equal to 0. So that's the logic behind just kind of getting rid of the constant. So then we still have 3x plus 2 equals 0, 4x minus 3 equals 0, 3x equals negative 2, x equals negative 2/3. 4x equals 3, x equals 3/4. Now, of course, for any one of these, you can check. So you can go and take any one of these values, put them back into your original equation, which are such that, and make sure that it equals 0. The zero product law can be used to solve any quadratic equation that is factorable. Utilize this technique, the problem must first set the equation equal to 0. Okay, so whenever you see an equation that has an x squared in it, anytime you see that occur, you have to set it equal to 0. So bring everything over to the side that will make or keep the x squared positive. We do not want to deal with a negative x squared. We don't want to deal with it when we're factoring, and we don't want to deal with it when we're solving. So keep the x squared positive or make it positive. So that means everything from the right side is coming over to the left. So I have x squared plus 5x minus 24 equals 0. So now you're just back to factoring. Your basic way to factor, factors of negative 24, that give you 5. I know that 8 and 3 give me 5. I need a positive 8, negative 3. So it's x plus 8, x minus 3 equals 0. X plus 8 equals 0. X minus 3 equals 0. X equals negative 8. X equals 3. The next one, the 3x squared is positive, and this x squared is positive. So always move the smaller x squared. Always. So everything from the right side is coming to the left. It is not always right to left, but in these 2 examples it is. So then I have a 2x squared plus 9x minus 5 equals 0. Now we are arcing. So we have 2 times negative 5 is a negative 10. Factors of negative 10 that give me a positive 9 are 10 and negative 1. The 2x squared comes down, the negative 5 comes down. Plus 10x minus x. Group the first 2, group the second 2. Factor out my 2x, x plus 5. Force this to be x plus 5, take out a negative 1. Then we have x plus 5, 2x minus 1 equals 0. So x plus 5 equals 0, 2x minus 1 equals 0, x equals negative 5, x equals 1/2. And when you're writing your solutions, if they want it as an order, it would be negative 5, 1/2. Okay, we get little bracket sort of things. Do put them in order from least to greatest. When else is this used? This is also used when we're graphing. So consider the system of the equation shown below consisting of a parabola and a line. Find the intersection of these points or these curves algebraically. Okay. So what you're actually looking for is the point of intersection. So you are looking for when 3x squared minus 8x plus 5 will equal 4x plus 5. Now, when you have a parabola and a line, three things can happen. You can have a parabola and a line with 0 points of intersection. You can have a parabola and a line with 1 point of intersection. You can have a parabola and a line with 2 points of intersection. Of course, the line can decrease, the parabola can open down, but you can have 0, 1, or 2 solutions. So same process here, and it does say algebraically. So set them equal to each other. Again, bringing from the right over to the left. And we have 3x squared minus 12x equals 0. So remember, your first way you always try to factor is a GCF. So many times people will see this and try to break it into two sets of parentheses. But we have a 3x, and then x minus 4 equals 0. Same process, 3x equals 0, x minus 4 equals 0. Don't be so scared of this 3x equals 0. Just divide both sides by 3, you get x equals 0. Add 4 to both sides, you get x equals 4. So it says find the intersection points of these curves algebraically. You found the x value. So I would go to the line, because that's a little easier. If x equals 0, y is 5. If x equals 4, 4 times 4 is 16, plus 5 is 21. So then we have 0, 5, and 4, 21 is the solution. All right, so those are the intersection points. So it happened to be 2. Using your calculator, sketch a graph of the system on the axis to the right. Be sure to label the curves with the equation, the intersection points, and window. Verify. Okay, I'm just reading what he has here. You can watch, because you go to the graph. Oh, I was there and I got out of it. So when you plug them in, you have your 3x squared minus 8x plus 5. Nobody's here to correct me if I put something wrong. Put it in, tab it for the next one. And then we have 4x plus 5. Enter. Okay. So you can see 1 point of intersection. If we want to find intersection point, menu, analyze graph, intersection, lower bound, upper bound, right there, 0, 5. Okay, there's another one. Menu, analyze graph, intersection, lower bound. Get to the right of that. Enter, upper bound, far to the right. Enter, it'll zoom out for you. 421, there's the other one. So we've seen that in class. I know you've done it in the past. So just a little review. Exercise 5, there's the parabola as the equation x squared minus 2x minus 3. Write the coordinates of two x-intercepts of the graph. So the coordinates of the two x-intercepts, so we have here and here. So it looks to be negative 1, 0, 3, 0. Find the x-intercepts of this parabola algebraically. So looking up here, I'm factoring x and x. Factors of 3 that give me 2 are 3 and 1. It's got to be a negative 3, positive 1. They got to equal 0. X equals 3. X equals negative 1. So that's showing it algebraically. Okay. Algebraically, find the set of x-intercepts of zeros for each parabola given below. So what we're doing is factoring. So when you factor this here, look for a GCF, no GCF. Okay? Second way to factor is your difference of two perfect squares, and that's what that is. 2x plus 1, 2x minus 1. They both equal 0. So we have x equals negative 1/2, x equals 1/2. Okay? Next one, b. All right, you try for a GCF. It really looks like there is one, but there's not. So we have a negative 30, and I have to get a positive 13. So it's 15 minus 2. 3x squared plus 15x minus 2x minus 10. They equal 0. Group the first two, group the second two. I know I'm going kind of quick, but this is all your arcing, like I think it was lesson 3. So if you need to go back and watch lesson 3, maybe you missed it, maybe you didn't understand it. The more you work with it, the better you will get. I take out a 3x of the first set of binomial. I'm left with an x plus 5. Force this to be an x plus 5, so I need to take out a negative 2. I have 3x minus 2, and then x plus 5. So then x equals 2/3, x equals negative 5. Last one, take out a GCF. In this case, it's a 5x. X minus 2 equals 0. 5x equals 0. X is 0. X is 2. Okay? Now, that's algebraically. You can always check it in your calculator. So when I go to my calculator, a little slow near the end of the day. So there it is. Okay, go back to the main screen. We are going to do menu 3, 3, 1. Find the roots of the polynomial. These are all squared. So look at the first one. They're real. Okay. So I have my A is 4. My B, there is no B, it's 0. My C is negative 1. So go down, there's a negative 1. Hit OK, OK, enter. Boom, negative 1/2 and 1/2. Okay, should be what you have on your paper. Do it again for the second one. 3, 3, 1. Oh, degree 21. 2, real. Oh my goodness. Okay, so the degree of 2 is just the highest power. So it's an x squared. Enter. I'm putting in a 3, a 13. Oh no, I got to hit enter. 3, go down. Yep, 3, go down. 13, and negative 10. Okay, okay, okay. There it is, negative 5 2/3. You can always check. Okay, and the last one, menu 3, 3, 1. Degree is 2. I have a 5. I have a negative 10 for the B. No C term, so it's 0. Okay. And there is 0 and 2. Just like all the answers we had. Okay. So if you have any questions, I'm not here tomorrow. Okay. Or today, whenever you watch the video, I have a doctor's appointment. So you'll have the fluency to do. There will be a hand-in assignment that will be due after break. I'll put in your mailbox so that everyone is sure to get it and they don't forget it. All right. Okay. I will see you hopefully on Thursday.